Hello, welcome to another new section. We're kind of adding on to our systems of equations lesson here, except we're just doing three variables at a time instead of two. So with three variables, you're also going to get three equations to work with. So here's our first example. You see we have three equations. Our variables are x, y, and z. I do want to point out my z's and my 2's sometimes look similar. That's why I do my z's with a line through them so that I make sure I don't mess up or mix up my 2's and my z's. So that's something you want to pay attention to when you write out your z's as well. If your z's look like 2's, that might mess you up. Okay, so we're still using substitution and elimination. The only thing is we have to do more of it because we have three equations. So with three equations, your goal is to try to use substitution or elimination on two equations at a time. You can't do things with all three equations at the same time. That's too much. So choose two equations at a time. Try to eliminate or substitute to get rid of one of the variables, leaving you with two. And then do that again with the other two equations and try to eliminate a variable again. That way you'll be left with two equations with two variables. That is the goal. I know I said a whole lot of words right there, so let me show you how it's done. So first, I want to take a look at a few things to figure out like what's easiest. So as you can see, a couple of my equations here, like this one and this one, are both already set equal to x equals y equals. So that probably lets me think that substitution might be used, it might be easier. And then also, this first equation has just two variables, x and z. The second equation has all three variables, x, y, and z. Third equation has y's and z's. So based on what I'm seeing, I want to make sure that I eliminate one of the variables for two of the equations. So I'm kind of going to focus on the third equation here because I just chose it. But the third equation only has two variables, so that's good. It has one less variable, so that makes it a little bit easier to deal with, which means out of my other two equations, I want to somehow get rid of the x's because my third equation doesn't have any x's. So because my first equation already has it set x equals, I'm actually going to use substitution to substitute it into the second equation for the x there. That way, when I substitute the z's, this negative 4z minus 19 in for the x, in this equation, now I'll have just y's and z's, which is what I wanted because that'll kind of match up my third equation where I only have y's and z's. Okay, so here I took my first two equations and I substituted in the x here. So 5 instead of x, I wrote the negative 4z minus 19 plus z minus 4. Then I distributed, simplified, combined like terms, and ended up with this equation, y equals negative 19z minus 99. So that's the equation I got from combining the first two together and getting rid of x's. So now I want to use this equation along with my third equation here. See how the two equations now have two variables. Now it's kind of like what we used to do with just two equations and two variables. So that's your goal. Every single time you want to combine or eliminate, substitute in order to get rid of one of the variables first. So right now, out of our three equations, we've gotten rid of all the x's. So that's the goal. Okay, so now with these two equations, probably substitution is going to be good again because I have it set equal to y. So I can substitute it in here, or you can eliminate if you really wanted, up to you. So after substituting, I distributed, combined like terms, solved for z. Because now with my equation, my one equation only has one variable. Now I can solve for z. I'm just going to circle it so it's easier to find later on. But now that I have z, I want to solve for one of my other variables. So here, I want to use this to plug it back in to one of the equations where I only had two variables. So like the equation that I had, either this one or this one, because these ones only have two variables in it. Choose one of those, plug your z back in, and then you can solve for y. I'm going to choose this one just because it has smaller numbers. So plugging into a negative 5y equals z would be negative 5 plus 25. So that'll give me y equals negative 4. So again, I'm going to circle it just so it's easy to find. Okay, now I have both y and z now. So now I can just plug it back into one of the originals, whichever one you want, to solve for x. You probably want to choose one of the equations that actually has an x in it. Probably the first one. So I'm going to do x equals negative 4 times z would be negative 5 minus 19. So that would be 20 minus 19 is 1. So x equals 1. Okay. Remember, your final answer is basically talking about like where, if you were to graph it, where would the lines cross? Here we have 3 variables, so this is actually in 3D. It's pretty cool. If you ever want to look it up, I'm not going to show you right now, but you're basically graphing in 3D space. So that's what these coordinates are. When we graph in 3D space, when we write our coordinates, it's always going to go in alphabetical order, so x, comma, y, comma, z. So our final answer is going to be 1, comma, negative 4, comma, negative 5. For my next example, I'm going to have 3 equations with 3 variables again. This time, all 3 equations have all 3 variables. So, in this case, you want to choose one variable to get rid of out of all 3 equations. You just can't do all 3 equations at the same time. But remember how we usually like to have the number in front of that variable to be the same? Makes it easier to eliminate. So in this case, probably the y's would be the easiest because all of them have a 5 in front. And then we need a mix of negatives and positives to help us out. So for this one, you can only deal with 2 equations at a time. So because I have 2 negative 5y's, 2 negative 5y's, and then one that has a positive 5y, I'm going to use the first and the third equation because that'll eliminate the negative 5 and positive 5y. And then I'm going to do it again with the second and third equation together. So it's going to get split up. So I've rewritten it so that I have my first and third equation over here, my second and third equation over here. So between these 2 equations, I'm going to add them together to cancel out, eliminate the y's. In this one, it also turns out that the x's will get eliminated, so that's kind of nice. So this leaves me with negative 6z equals negative 18. So from there, I can just go ahead and solve for z. If I divide both sides by negative 6, I get z equals 3. Well, that's kind of nice. So now I already know what z is. But let's also eliminate the y's over here. So negative 5y plus 5y will cancel out. Then that'll leave me with 5x plus 3z equals negative 1. Okay. From here, since I already know what z equals, then I can use that to plug it back in to an equation with 2 variables, kind of like how we did before. So remember, you're trying to eliminate one of the variables altogether. So after we split them up into the 2, we got rid of all the y's. That left us with z's and x's and z's. So once I have that, then I can use this equation, since it only has 2 variables now, to solve for x. So that'll give me 5x plus 3 times 3, which is 9, equals negative 1. So solving for x, I get x equals negative 2. Okay, that's not so bad. So now that I have two variables solved, then I just need to plug it back into one of my original equations to solve for y. I'm going to choose the first one again. Why not? So negative x would be negative of a negative 2 minus 5y minus 5 times z. That'll give me y equals negative 3. Okay, then our final answer, remember we have to write as a coordinate again in alphabetical order. So x, y, z. There we go. For my last example, this time I'm going to use ABCs just so that I don't have to keep writing x, y, z. But again, I have three equations. All three equations have all three variables. So that means I need to choose one of my variables to get rid of. And here, it's really up to you. So it looks like out of all three variables, I'd have to multiply or something in order to eliminate any of them. So I'm just going to go with A's because it's the first letter of the alphabet, and I'm really hoping you guys get A's on this quiz, and so on. So let's get rid of A's. So in order to do that, it looks like 2 and 3 would be really easy to eliminate because they already both have 4's in front of the A. So then I just need to do something with the first equation. So I'm going to do eliminate A's from the second and third, and then I'm also going to eliminate from the first and third, just because this one's positive, this one's negative. But again, you could have done the first and second, doesn't matter. Now that I've written out my two sets of equations that I want to eliminate from, I'm just going to go ahead and start eliminating. So get rid of the A's here. This will end up being 6b plus 6c equals 3. In this set over here, I'm going to have to multiply the top by 4 and the bottom by 5, and then I can eliminate. Okay, so this is me multiplying by the first equation by 4 and the third equation by 5. And then I could eliminate the A's to leave me with 35b plus 35c equals negative 35. So now as you can see, I have two equations with b's and c's in it. So I want to use these two and do elimination from here to get rid of one other variable. I think I'm going to eliminate b's. It looks like both of them I'd have to multiply by the same thing. Okay, so from these two equations, I multiplied the first one by 35 and the second one by negative 6. That way I have the same numbers for b in front. That gave me 210b plus 210c equals 105 in the first equation, and then the second one gave me negative 210b minus 210c equals 210. So now I can eliminate, and whoa, weird, all my variables eliminated. If everything eliminates, that really means you have 0 left over on that side. And then on this side, if we add them together, we end up with 315. So now we're left with this equation, 0 equals 315. Is that true? Heck no, 0 is not equal to 315. So because that is false, this ends up being no solution. We weren't able to solve for any variables. That is it for my three systems of equations. My recommendation to you for this section is to be really careful. It's really easy to make like a small mistake somewhere with a negative sign or something like that and messes up all your answers. So again, be really careful, go slowly, don't try to rush through it. But each time, remember you want to use elimination or substitution to get rid of one variable from all three equations, and then that should leave you with just two equations and two variables. Once you're there, you want to use substitution or elimination again. That way you can get rid of one more variable, and that'll just let you solve for the last one. Once you have that, plug everything back in, and then you should be able to get your final answer. Remember, your final answer has to be written in coordinate form, so alphabetical order. All right, that's it. Good luck on the homework.